Okay, gentlemen, here we go. Super easy lesson today. I mean, super easy. As you would say, hella easy. So pay attention. I'll make it as simple, quick, and painless as possible. Okay, we went over Ohm's law, just the basics of it. Before we move on to calculating total resistance, you got to know like what kind of circuits there are. Now, there are only three kinds of circuits, so this should be easy for you to remember. So I'm going to put the three kinds of circuits up here, and I'm going to show you how to calculate resistance in a series circuit and in a parallel circuit when you have two resistors that are the same value. It only works for that. We'll get into the more complicated stuff next week, but this is the real simple stuff. And the first circuit we're going to have is called a series circuit. Now, series circuit, we've been working with those for a week now. It's just, when working on Ohm's law. So you should be familiar with it. You may not know that it was a series circuit, but that is what it's called. Now, a circuit has three things, remember? A circuit has three things. It has a voltage source. Okay, this particular voltage source, that's a symbol for a battery. Okay, if it was a generator, it would be drop bigger so I can put a G inside. There would be a generator. There would be a motor, which is not a voltage source. This is a load. That's a voltage source. So, but since those two are similar, the G will make it a generator. The M will make it a motor. But in this case, we're going to use a battery. So remember, generator, well, never mind. We'll keep it simple. Battery, that's your voltage source. Conductors, right here. Here is a symbol for a resistor, which is, in this case, a load. So there's the three parts of a circuit: a battery, conductors, and a load. Symbol for a battery, symbol for resistance. Now this is what you call a series circuit. And the reason it's a series circuit is because current flow only has one path to flow on, okay? Out from the battery, then back to the battery. Now, right now, you just got one resistor, but let's put some more resistors in here so you can understand that this is a series circuit because these resistors are all in series with each other. Whatever current is flowing through this resistor has to flow through this resistor. It has to flow through this resistor. There's no place else for it to flow. You can't jump over it and go to this one. Whatever this one sees, this one sees. Whatever runs through here has to run through here. All right? So this is why they call it a series circuit, because all those resistors, you could put 2, you could put 1, you could put 6 trillion billion. It don't matter. If they're all hooked end to end to end, just like that, then they're going to be series because they're all in series. That means the current that flows through one resistor in a series circuit flows through all the rest. There's no other way about it. So this is going to be number 1. And number 2 is going to be a parallel circuit. Now, parallel circuit is similar in that every circuit has to have a voltage source. There's our voltage source again, the battery. Come around. Guess what? Is that a parallel circuit? No. It's a series circuit. It's like this one. Now, that's about as simple of a parallel circuit as you can draw. That's because your current flow is going to come out from your battery. It's going to go through this resistor, okay? But not all of it. Some of it's going to come down here. It's going to go through this one. So all the current that's flowing in this circuit doesn't flow through here. Some of it flows through here. So it flows through both of these. So there's formulas to figure out how much is going to flow in each one. Right now, we're just going to today talk about, how much flows when they're both equal. So we're to figure, the total resistance. So right now, you've got a series circuit, a parallel circuit. Now this, remember I said you could have a bazillion circuits in a line, all hooked, beginning to end, or end to beginning. You know what I mean? Hook end to end, like all this all the way around. No matter how many you have, still a series circuit, as long as they're hooked end to end like this. The same thing with a parallel circuit. You can have more than just two. You can have a bazillion right here. Okay? So in a series circuit, even though you can have a bazillion of them hooked through there, that current has to flow through every single one that you hook in, even if it's 1,000. If it's 1,000 resistors hooked end to end, that current has to flow through every single one. But if you got 1,000 here, there are all kinds of places for it to run. There's 1,000 different places for it to run. So this is why when you have more resistors in a series circuit, your resistance goes up. Remember, resistance is opposition to current flow. Anything holding that current back, slowing it down, making it harder for it to run, is considered resistance. So the more of these resistors it has to run through, the more resistance you're going to have. So in this case, you would just add these up. We'll do that in a second, but I want to get this concept to you first. In a parallel circuit, the current can run all these bazillion. If you got 1,000 of these resistors, the current can run through that one. Some of it can run through that one. Some of it can run through that one. So it's more places for it to run. So if you got more places for it to run, all in parallel like that, it's going to be less resistance because it's got more places to run. So this could have 1,000 resistors. This could have 1,000. So this still only has one place for the current to run. It has to run through every one of those 1,000 resistors. So it's going to be a lot of resistance. But if you got 1,000 resistors in parallel, it's got 1,000 different places to run. So that means it's gonna, the more resistors you have in parallel, your resistance is going to go down. You'll have less opposition to current flow. It'll be like how much water flows in a hose compared to how much water flows in 2 hoses, 3 hoses, 1,000 hoses. So that's what happens when you get into your parallel circuit. So let's talk about the third kind of circuit, which is number 3. This is going to be a series parallel. Okay, all that is, this is no new thing. This is just a combination of these two. For instance, here we are with a circuit. We have a voltage source. We have a load. There, I have just drawn a series circuit. Now we're going to change it into a parallel circuit. Okay. Before we only had one path to flow, now we got two to flow. Turned it into a parallel circuit. So how do we turn this circuit into a series parallel? Well, we add one or more. It doesn't matter how many you add. You add another resistor or another load here. This one is in series with these two, meaning that whatever current flows through this resistor right here, it's going to have to flow through one of these two. Now, these two are parallel, but whatever flows through these two has to flow through this one. So this puts it in series with these two. Now, if you had two of them, then you would just have a parallel circuit. You know, if you come off of here and drew another one out here and come down to here, it would make it parallel. But I'm trying to keep this so simple because I want you to get the concepts. Concepts. The concept is a series circuit. The current has to flow through every single resistor or every single load on that circuit. It can't go anywhere. It has one path to flow. Parallel circuit, it has multiple paths to flow. That just depend on how many you want to put in there. So therefore, your resistance is going to be less the more parallel resistors you put in. On a series, the more you put in, the resistor is going to be more because there's only one path for it to flow. Where this one, I mean, it can choose to go here, go here, go here. It's like one hose of water compared to 1,000 hoses of water. On this one, this would be like one hose of water down here hooked into two hoses, okay? You hook one hose on your faucet, and then you put one of those Ys in there, and now it's got two places for it to flow. So at first it starts out flow in series, then it flows in parallel. Now you can do the same thing over here. It doesn't have to be first. We can put another resistor over here, okay? It would go series, parallel, series. You wouldn't call it a series parallel series circuit. You would just call it series parallel. It's all the same thing because it doesn't matter where it is. Usually on this stuff, when you're calculating total resistance, your voltage source just sees total resistance. It doesn't see all the individual ones. So it doesn't really matter if this one's here or here. But there you go. There are, very simply put, three kinds of circuits: series, parallel, and series parallel. Again, the series is when they're hooked end to end and there's only one path for the current to flow on. And it has to flow through every single one. And every time it flows through another one, it's more pushing back. Flows through another one, more pushing back. In a parallel circuit, has 1,000 different ways to go. It can go around and say, oh, I'm going to go through this one. Another one, I'm going to go through this one. And these other electrons, we're going to go through here. So it doesn't have to go through every single resistor. It can choose which one it wants to go through. And so there's not as much resistance. Actually, there ends up being less because there's so many ways to go. And this is just a combination of the two. You know, at first, you might have a lot of paths to flow here, but it doesn't matter. Everything has to flow through this guy right here. And it could choose a bazillion paths to flow through here, but in the end, it all has to flow through that one. So let's look real quick, now that we understand that concept, like, well, how do we calculate? How do we calculate the resistance in these simple circuits? Since all the current flow has to flow through every single one in a series circuit, then it only makes sense, like if this one is 10 ohms, and this one's in 10 ohms, and let's say this one's 5 ohms, you just add them up, because it has to flow through that one. There's 10 ohms of resistance. Oh, it has to flow through that one. There's 10 more, that's 20. Has to flow through that one, that's 5. So your total resistance your total ohms is going to be 10 plus 10 plus 5, which equals 25 ohms, okay? If this was 1,000 ohms, it'd be 10 plus 10 plus 1,000. So it would be 1,200, I'm sorry, 1,020 ohms. You just add them up. And the reason you add them up, because that current has to flow through every single resistor. So they all add. It runs through one. It's got to go run through another one. You got to run through another one. They all pick and add up. In this case here, it's a little different. Because we got two paths for it to flow in. Now today, I'm not going to give you like the formula how to solve this. I'm going to show you a trick. We'll go over the other stuff next week. And you'll appreciate this, so you don't have to calculate stuff. You can just look at it and immediately know. And the trick is it's not really a trick, but it's a formula that's so simple, it's like a trick. For instance, this one is 10 ohms, and this one is 10 ohms, okay? When you have, we'll call this R1, we'll call this R2, okay? Resistor 1, resistor 2. When you have two resistors in parallel, in a parallel circuit, okay? You have two resistors in parallel, and they are the same value. That's the deal. They have to be the same value. It works out that your total resistance is always going to be half of one of them. So half of 10, your total resistance, or your total ohms here, your total ohms is going to equal 5 ohms. Because that's the trick. Is I don't care if this was, well, let's make these 1,000. You got 1,000 ohms. 1,000 ohms. Half of it is going to be, half of 1,000 is going to be 500. You don't even have to like think of anything. If R1 was, I don't know, 40 ohms, 40, and your total resistance, you already know half of 40 is 20. So it's going to be 20 ohms. So now if we come over here, we do the same thing over here and play around with these guys. You know, 10 ohms in series is going to be 20 ohms. This is going to mess you up. 20 ohms. Remember, these are 240 ohms. Let's just do this. 10 and 10 in series equals 20 ohms. 10 ohms and 10 ohms are going to be half of your 10 ohms. It's going to be 5 ohms. Okay? So we change this to, let's change this to, I don't know. Let's change this to 60 ohms. 60 ohms, that's going to equal 120 ohms. Change this one to 60. 60 ohms and 60 ohms. Remember, it's going to be 1/2 of one of them. So that's going to give you 30 ohms. So this works in a parallel circuit when you have two resistors of the same value in parallel. Super easy. You just take half of one of them. This, you just add them up. Super easy. If you can add, you can do that. If you can divide something in half, you can do this one. Now in a series parallel, let's say, let's use the same values. Let's say that these two are 60 ohms, okay? 60 ohms, and 60 ohms and 60 ohms. So what you want to do, this is a trick, you might as well learn it right now, is you want to solve for your parallel circuits first. And so anything that's in parallel, you want to solve for it first. You want to simplify it. And you want to get that total resistance. So we're going to look at this. We already know that two resistors in parallel is going to be half of one of them when the value of the resistor is the same. Let's say this is R1, R2, R3. And we're going to look at R2 and R3. We got 60 and 60. They're the same amount, and we know they're in parallel, so we automatically know that's going to equal 30 ohms, right? It's like over here. This part is the same as just this part. We take it out. Now, we also know that everything that flows through these two has to flow through that one. So now we have one path. This is the one path. It goes through here, and then it goes through these two. So this is a part that's series. So when you have this 30 ohms right here, which are these two in series with this 90 ohms, then you add them, okay? So that'll be 60 ohms. You add those up, and you're going to get 90 ohms. 30 plus 60 is 90. So again, just to give a quick review, and then I'm going to call it. Series, you just add them up, okay? Parallel, when the values are equal and there's only two of them, it's going to be half of one of them. And then a series parallel, you want to solve for your parallel circuit first, and then this whole part here is in series with this one right here, and then you're going to add them. So there you go. Simple as that. There's your series parallel and series parallel, and a little bit on how to figure the total resistance for each type of circuit. Now, when we get into multiple parallel circuits of different resistors, we get into multiple resistors of different values, I'll give you the formulas for that. So, and then we'll start calculating some different stuff. We'll do that next week. So anyway, all this be on your quiz on Thursday, and peace out. If anybody's got any questions, let me know. Now's your chance to speak up.